Hello, everyone, and thanks for joining us. I'm Mark Gamble, Director of Product and Solutions Marketing for Couchbase, and it's my great pleasure to moderate this discussion on edge computing for blazing fast apps and services, how AWS, Verizon, and Couchbase deliver ultra-low latency. So in the program, we'll talk about the architecture, the components, and explore the emerging edge services landscape. But first, I'd like to introduce our distinguished panelists who are experts on the topic of edge computing. So please help me welcome Rob Czarnecki, Principal Product Manager, AWS Outposts, Savi Venkatachalapathy, GTM Specialist, AWS Wavelength, Pranav Chatra, Senior Product Manager, AWS Local Zones, Brent Eiler, Principal Architect, 5G Edge at Verizon, and rounding out our panel, Wayne Carter, Vice President of Engineering at Couchbase. So thanks to all of you for being here. It'll no doubt be a great discussion and an exciting session. So to start, we'll take a moment to examine edge computing. Why is it that this architectural model is so hot? As you'll see, it's about speed, reliability, and security for applications. So analyst coverage on the topic of edge technology has been increasing, all emphasizing the growth of edge computing over cloud computing for faster processing and resilience to internet latency and outages. So the pendulum is swinging away from cloud-only based computing driven by the touchless economy and the growing proliferation of devices and applications that require high speed and resilience to internet problems. Cloud computing, of course, offered a great option for scale and cost reasons, but it also relies heavily on internet connectivity. And this introduces a point of failure over which there's really little control. And in the case of mobile or IoT devices, a constant change of location only exacerbates these problems. And there's also the challenge of data governance, where data is restricted from living in the cloud for privacy or sovereignty reasons. So these sorts of challenges really spurred a shift in the application architecture approach, especially for specific applications that require ultra-low latency, which are just simply better served by capturing and processing data at the edge. Edge computing, as such, is emerging as a strategic approach for application architecture, really seen as much more than just an extension to the cloud. It's really all about distributing the cloud to the edge. So these are the three most important value points, those key tenets, if you will, for edge computing as generally defined by the market. And first, we have speed, which of course addresses the inherent latency of a cloud-centric application model. Cloud, of course, offers benefits of scale and flexibility and cost savings, but in many cases, the data is just too far removed from the application to facilitate the real-time performance that it might require. And trying to achieve that level of speed solely through network means is simply just not feasible. Applications like those in gaming or healthcare, manufacturing, and the like, where in-transit data volumes can be high and low latency sub-millisecond response times are really critical, regardless of internet bandwidth. Simply can't be served with a cloud-only model. So moving computing to the edge is the only way to gain that necessary speed critical for these types of applications. Next is reliability. This is about increasing guarantees of uptime by providing uninterrupted access to data regardless of internet connectivity. So having a reliable method of data access that can withstand the inevitable connection issues helps better ensure application performance and when operating in areas where internet connectivity is unreliable. And security, which is all about data privacy, governance, and regulatory policy compliance for applications that handle sensitive data. Because a key value point for edge computing is that sensitive data never has to leave the edge. So here's a quick component overview of the Couchbase stack. These are the products that support mobile and edge computing from a data processing standpoint. So on the right, you have Couchbase Server. This, of course, is our flagship modern multi-model NoSQL data platform, which runs in memory and supports SQL queries, transactions, analytics, full-text search, and eventing, and much more. Then on the left, you have Couchbase Lite, and this is a fully featured NoSQL embedded database, a version of Couchbase, if you will, for embedding on mobile and non-mobile embedded platforms and applications. Sync gateway here sits in between, and it's responsible for secure data synchronization, routing, and access control between clients and server tiers. So a key characteristic of this stack is that you can deploy it in the cloud or edge data center. You have complete control over where and how Couchbase is installed. So this is how Couchbase fits seamlessly into the edge computing architecture. So now I'd like to hand it off to Wayne for a few minutes to describe the architecture and explain why it's so fast and reliable. And he'll take a moment also to talk about the latency test results that his team saw when testing the edge services. So Wayne, over to you.
Thanks, Mark. So I think for a lot of engineers and architects, edge computing isn't something they're super familiar with. And yet it turns out, as you described, that edge computing is becoming really common in enterprise technology world. And in fact, sectors like gaming, retail, healthcare, travel, utilities, and transportation, the use of edge computing is increasing by double digits year over year. And we introduced the first NoSQL database and sync for edge computing back in 2014. It was a first for the NoSQL market. And since then, I've had a lot of people reaching out to me, asking me about how edge computing can help their business, its unique architectural guarantees, the options for physically managing its highly distributed compute systems. And in the next few slides, I hope to answer a number of those questions and then continue to answer those as we move further through this talk. So looking at the key benefits of edge computing, these are architectural guarantees that are provided by augmenting your cloud architecture with the distributed resources that come with edge computing architectures. And from the business side, this maximizes business uptime, speed, and governability of your digital systems that play in your business critical processes. And on the architectural side, you're going to get the highest availability, the lowest latency, and you'll have the most governable set of data as compared to a non-edge computing architecture. So starting with cloud computing, you have, and this is highly simplified. Of course, this could be more complex if you would like, but this really touches on the differences between cloud computing and edge computing. So I wanted to start with this very, very simple deployment architecture. So in this case, you're deployed in the cloud. We're imagining this as the west region of US, and you have a database deployed and a web services deployed. And then you have clients accessing those web services and data via the internet over a wide area network. If you move to edge computing, you're adding additional layers of compute and additional layers of networking. So in this case, what we've slotted in here is an edge compute environment that has storage, networking, and compute in an intermediate tier near the edge. And it's also added a new networking layer with 5G, ISP, or LAN as your options for that layer. And then a client tier with additional compute, networking, and storage, and adding the last networking layer that's added here, which is the private area network. And I'll show how all of these play together as I progress forward from here. Okay, as we expand towards the edge computing architecture, we've added in the extra layer near the edge, and now we need to duplicate our service and database down to that edge. Once we've duplicated it, we now have access to the web service and access to the data at the edge, and we need to redirect the client. And then we connect the edge to the server via the database through synchronization. Now, if we wanted to make this available across multiple availability zones, we would duplicate the availability zone along with the edge computing resources that we had in the original west zone. So let's call this east. And then we duplicate the services and database from the original zone over to the new zone. And then we connect the databases from west to east. And now you have a full, this is very simple, but a full edge computing architecture that spans multiple regions. Now let's make this a little bit more interesting by adding a new city. So down at the client layer, we had San Francisco and we had New York, which are paired with our edge compute regions. Now we're going to bring in another city that actually doesn't have a paired edge computing region. So bringing in LA, put a device in that area, and then have it connect to the West database and its services. We'll make this a little bit more interesting by introducing a few additional clients in the LA region and look at how you could solve the edge computing problem directly on device. So in those two additional devices, we're going to put an embedded database in those. And then we're going to connect those to the database directly through synchronization in the West region. And then I wanted to show how you use a private area network so that if you lose connection with the West region, those two devices that have the embedded database can continue to share database with data with each other. So if data changes on one device, it's shared with the other and vice versa. So we have a great options for network resilience, both at the high level cloud region, down to the edge regions, and directly on device. And so if we look at the way you would manage the operational management of this prior to last year, you had really two operational options. So you had to either first manage the physical devices with users bringing the compute and networking and storage on their phones and tablets, and then operationally manage those devices using the App Store platforms. And this was an efficient approach. It is an efficient approach, and it offloads the majority of operations and the operational cost to the user and their devices. And then the second approach you had prior to last year is to manage on-premise systems. And operationally, that's a complex option, but it does have a lot of benefits. So in many cases, the cost is worth the complexity. And what we actually see in a lot of our customer base is in many cases, they use both. So they use managing the devices themselves and using the compute there, and also managing on-premise systems to have the optionality of going up to a higher tier for many cases. But now, with AWS Edge Computing Solutions, the operational complexity of managing on-premise and near-premise systems can be offloaded to the AWS operational teams. And so a lot of that complexity goes away, and it just leaves the business benefit of edge computing. And then Verizon handles the ingress and egress between on-premise and wireless networks, which delivers the uninterrupted business continuity as you move between these types of environments. And then from the Couchbase side, Mark covered this in a bit in the beginning. We have Couchbase server and sync gateway that run in your cloud environments, and those run in AWS regions and availability zones. Server and gateway can run in the edge environments also, Wavelength, local zones, and Outposts. And you can also use Couchbase Lite in that tier for many cases. And then Couchbase Lite, of course, runs directly on the device, and Verizon providing the connectivity at that layer. And so now let's look at the latency tests that we ran. So early when these services came out, we started getting a lot of questions on the optionality that it provided, and we wanted to look at how it affected the key values around edge computing. And we focused heavily on latency first, because that's one of the biggest things that we hear about. And during that focus, we ran a series of tests on the AWS services, and I'd like to share the details with you here. So this is the architecture for our first test with Wavelength. We connected to the US West zone for our server deployment and our cloud deployment. And then we did the US West to SFO Wavelength zone for our Wavelength deployment. And each of those zones, we deployed identical deployments of Couchbase with a web service providing RESTful access to data within the Couchbase database. And we deployed those in both of those areas. Then we accessed those in parallel, measuring the latency both on the network, at the client level, full round trip. We even measured server latencies and database latencies, just to measure everything in the entire compute and networking stack. And doing that from a 5G enabled device, we actually use an iPhone 12 Pro connected via Verizon's ultra wideband service to run all of these tests. And the test results were pretty significant. So these were get set operations using a 1,000 byte payload for both sides of the operations. And the blue and red lines are showing the results we got out of the cloud deployment, and the green and yellow lines are showing the latency we got out of the edge environment. And so a 67% decrease on the gets and the 82% decrease on the sets, a massive increase or decrease in latency that really allows you to get 3 to 5 times X more work done in the same time frame with those types of reductions. And then we did a test on local zones. And so for the local zones architecture, the test architecture was actually identical. We connected to US West for cloud, and then we did an LAX region for the local zone. We deployed the identical services out to those areas and then access those via a desktop over wired ISP in the LA area. And for those results, we saw similar decreases. So 79% decrease in reads, 78% in the sets. So that's a 5x increase in the amount of work you can get done in the same period. And the red and blue represent lines you see here are representing the cloud, and the yellow and green are the edge zone. So a massive increase in performance and speed through that reduction in latency by bringing that compute. And it's really about bringing the compute, storage, and networking closer to the point of interaction. This is very much a locality problem, and a big way to reduce latency is to bring things closer to you.
Great. Wow, fascinating stuff and amazing results, Wayne. I agree 100%. And it really, takes the debate off the table about edge computing, reducing latency. It does by an order of magnitude, as your tests showed. So let's get into our panel questions. And I'll direct the first question to Savi. So Savi, it's clear AWS offers customers a lot of options and flexibility with multiple cloud and edge services to choose from. But with that flexibility can also come some questions, such as, what's the difference between these services? So I wonder if you can help our viewers understand the various AWS services that are available.
Sure. Thank you, Mark. So if you look at it at the core of digital transformation are applications, and applications have different needs. While most applications can easily be migrated to the cloud, some applications need to be re-architected or modernized before they can be moved to the cloud, and some need to remain on premises for foreseeable future due to low latency, local data processing, or data residency requirements. And these applications need to reside in on-premises data centers, branch offices, manufacturing plants, restaurants, edge nodes in large metro areas, at the edge of the 5G network, and other remote locations. However, what we are seeing is there is an emerging class of new applications that require ultra-low latency, such as real-time gaming, video streaming, AR/VR, autonomous vehicles, content creation, AI ML-based inference at the edge, etc. And these applications are deployed in on-prem data centers, branch offices, etc. And often users access these ultra-low latency applications from mobile devices, so they might need to be deployed at 5G network edge to take full advantage of the speed and bandwidth benefits of 5G. And another trend we are seeing is that as customers go through digital transformation, there's a growing number of IoT devices, sensors that generate enormous amounts of data, petabytes of data, and some of these data sets need to be processed locally closer to where the data is generated because they cannot be easily migrated to the cloud due to cost, size, bandwidth, or timing constraints. So regardless of where their applications may need to reside, customers want to use the same infrastructure, services, APIs, and tools, and customers want a continuum of consistent cloud services that extends from regions to customer on-premises to remote locations that allows them to operate seamlessly across a multitude of environments. AWS with Cloud Continuum is addressing exactly that, bringing AWS cloud services to where our customers need it, be it on-premises data centers, branch locations, manufacturing plants, large metro areas, 5G networks, or other remote locations. So with AWS Outpost, we're bringing native AWS services, infrastructure, and operating models to virtually any data center, co-location space, or on-premises facility. And customers can use the same APIs, the same tools, same hardware, and same functionality across on-premises and the cloud to deliver a truly consistent hybrid experience. And AWS local zones are a type of AWS infrastructure deployment that places AWS compute, storage, database, and other select services closer to large population, industry, or IT centers where no AWS region exists today. Each AWS local zone location is essentially an extension of the AWS region where you can run your low latency sensitive applications using AWS compute, storage, networking, and other services in geographic proximity to end users. And wavelength zones, AWS Wavelength, brings AWS services to the edge of the mobile network, minimizing the latency to connect to an application from a mobile device. And in partnership with communication service providers such as Verizon and others, we deliver a global network of wavelength zones, AWS infrastructure deployments that embed AWS compute, storage, and other services within our telco carrier partners' data centers at the edge of 5G networks. And then we have AWS Snow family of ruggedized devices for on-premises environments with intermittent network connectivity, such as cruise ships, remote mining locations, etc. All in all, like with AWS Cloud Continuum, we are bringing AWS Cloud to where our customers want.
Great. That was a really comprehensive answer. Appreciate that. I think it starts to really clear up some of the questions. So let's direct the next question to Rob. So with that great, understanding of that great description that Savi gave of the AWS Cloud Continuum, there's a variety of architectural topologies that customers can actually leverage. So can you describe Outposts and talk a little bit about the considerations that a customer has to take into account when evaluating and deciding on the right service for their needs?
Absolutely. And I think Savi really described it nicely, right? That Outposts are what allows us to bring our AWS infrastructure outside of our data center. We're available in 60 countries today, and that list continues to increase, may even be more by the time this airs. You can connect those, what we call home, to an availability zone in any AWS region. And as new regions come online, we'll support those connections to the new regions as they're live. And it's important to remember that Outpost hardware is the same hardware that underpins the new local zones we're launching and the wavelength zones. So we really allow customers with Outposts to be out there and make them the tip of the spear in a sense. And if a customer needs a workload, maybe in a facility where it's dedicated to them and it wouldn't make sense to have a multi-tenant deployment, perhaps that's just because of the specific physical requirement, or perhaps that's because of a contractual sensitivity or a regulatory requirement. They have the flexibility to deploy Outposts on their own exactly where they need them with just the capacity they need. And then we can continue to deploy local zones and wavelength zones where it makes sense for our customers and partners. The nice part about these new Outpost-based infrastructure deployments are it's the same AWS that customers are familiar with, right? That EC2 compute on your Outpost, it's just another subnet that's available in the EC2 console in your home region. So any applications that you've built in AWS, they'll just work on your Outpost. And we have examples of customers. Riot Games is a great example. They were one of our early Outpost adopters and one of our initial references where they deployed Outposts in locations that made sense for their gamers, that meaningfully reduced the latency. And they were able to migrate that application that was running in the region within a day and have internal employees testing the game engine. It's just that easy because it is the same AWS APIs and tools and services that's running on the same hardware. And it's our same in-region control plane that's managing that. It really lets customers not change their architecture and bring the cloud wherever they need to be. It's worth adding that the Outposts can be deployed really nicely next to existing customer infrastructure or in net new locations where the customers don't have infrastructure and don't want to be bothered with managing the hardware and patching the firmware and all of that. Just like we do in the regions, AWS handles everything up to the hypervisor. The customers provide the physical space, the power, and the network connection. That's the only real difference from the region. And within that rack, we manage it just the same that we do capacity in the region.
Great. Thanks for that answer. It's becoming increasingly clear why this is catching on, and the fact that it really is about extending the cloud closer to where the data happens, and as a result, things just naturally go faster. So it becomes incredibly clear. Pranav, let's come to you. So, can you describe how and where local zones fit into the spectrum? I know we sort of heard about them at a high level when Savi gave the overview of the continuum, but would love to hear your thoughts on where local zones fit in the spectrum and how it differs from the other AWS Edge services.
I think it's a great question. As Rob called out, AWS Outposts is designed for workloads that need to remain on premises. And that's typically due to strict latency requirements. However, not every customer wants to operate their own on-premises data center. In fact, there are customers who are interested in getting rid of their data centers entirely. And that's where local zones come into the picture. Local zones allow such customers to gain all the benefits of having compute and storage closer to end users without the need to operate their own data centers. So let's take an example of US West Oregon region. We know that the latency of applications deployed to the region depends on where the end users are and where the region is, and the specific path traversed to reach the applications in the region. And typically, the latency in regions is in the order of tens of milliseconds if you look across broad population of end users. What AWS Local Zone does is that it brings AWS services to the edge in these metropolitan areas, which minimize the latency required to connect to end users. Logically, you can think of local zones as very similar to availability zones and regions. It's just that these zones are not physically co-located with the region, and instead they lie in a different physical geography. So in the case of LA local zone, what we've done here is that we extended our Oregon region into the LA metro area by building 2 local zones in LA. And since the path traversed is shorter from end users in the Southern California area to the LA local zones, the latency is lower and predictable, which is what is essential for applications such as gaming and hybrid migration. So far, we have launched 10 local zones in major metros, including Boston, Chicago, Houston, LA, and Miami. And we're also launching local zones in 6 additional US metros later this year, covering cities like Atlanta, New York, and Vegas. And the overall goal here for us is, in general, to allow our customers to deliver a single-digit millisecond latency experience to end users across the continental US.
Excellent. Thanks, Pranav. Appreciate that. And Savi, I know that you talked a bit about Wavelength up front in the, amongst all of the services. Any thoughts that you'd like to sort of, as we close out, on the differences between these services on Wavelength, on where it fits and how it differs from the other services you described?
Sure. So like I said, AWS Wavelength brings AWS services to the edge of the 5G network, reducing the latency to connect to an application from the mobile device. It's essentially AWS infrastructure, our own top-of-rack switches, servers, AWS disks, power distribution, cabling, etc. And it's located and installed in the physical site that is part of our CSP partners' mobile network. And application traffic can now reach the application servers in the wavelength zone without leaving the mobile network. So UE devices have access to the instances services in the wavelength zone over the CSP partners' 5G network without ever having to go across the internet. And we have 17 wavelength zones generally available, 13 here in the US with Verizon, and 4 other wavelength zones across other CSP partners globally. And the wavelength zone, given that it's present at the edge of the mobile network, it allows processing the data closer to where the data is being generated or closer to where the data is being consumed. And if you look at a typical mobile application, talking to an endpoint in the region, the typical path is from the UE device over the carrier's mobile network through their packet processing pipeline and then their backbone and multiple hops across the internet before hitting the endpoint in the region. And depending on how many hops it takes across the internet, the round trip time latency could be anywhere from tens of milliseconds to a couple of hundreds of milliseconds. And mobile application traffic with servers running in the wavelength zone, now you can basically traverse the mobile network and then hit the servers in the application running in the wavelength zone. And since the network path traversed is shorter from the mobile UE device to the wavelength zone and highly controlled by QoS and routing policies, we can provide a predictable latency, and it has less jitter. And this is crucial for applications such as live video streaming and distributed databases. And also I want to call out that with wavelength zones, we deliver a consistent developer experience across multiple 5G networks around the world, allowing you to build your applications once using the same familiar AWS services, and you can deploy that application across wavelength zones globally. And with that being said, I want to mention with wavelength, you get the capacity closer to your end users and where data is being generated, along with AWS benefits such as no capital cost, pay-as-you-go pricing, and the ability to scale up and down on demand.
Great, thank you. And I think this is a natural lead-in, actually, Savi, because Wavelength is, inherently connected with the network piece. So the next question, let's go over to that piece of the equation, if you will. Brent, Verizon, represents that critical piece of the equation, the network itself. So where does 5G fit into the edge landscape? And can you just describe that?
Sure, Mark. Yeah. And, like Wayne mentioned, I think Verizon is uniquely positioned here to address the larger environment that Savi and Rob spoke of and kind of stitch together that computing fabric from the on-prem to on the road, for these truly mobile workloads. We do this through a combination of private on-site cellular networking, 4G and 5G, the use of multiple SIM profiles, the larger Verizon macro network, providing nationwide 4G and 5G, where you see those wavelength zones residing, and then something called the Verizon Edge Discovery Service, which I want to touch on here in just a second. But to give you a quick example, think about manufacturing. You've got sensors, you've got cameras, they can exist completely untethered on the private cellular network, allowing for an easy reconfiguration as well as interaction with something like Outpost. As the finished goods are staged, they remain in the application that may be tied to that Outpost environment. They can report metrics to that local app, flag abnormalities. But what happens to my goods when they're in transit? Some of these goods may have critical attributes with maybe a low tolerance. If you think about pharmaceuticals like the new COVID vaccines that need constantly monitored throughout the process and could be worthless if a certain temperature is not maintained throughout. How can this be ensured as I move from on-site to off-site? As these lots roll out of the manufacturing facility, sensors can seamlessly transition to that Verizon macro network in the AWS Wavelength zone infrastructure, which in itself can integrate with the Outpost environment through EKFs in the Amazon region, like Rob was talking about. So not just the network, but keeping consistency throughout in the application environment, which is pretty cool. But the cool part that I wanted to touch on here, what's really cool is as we move to that larger public Verizon network and throughout transit, sensors in trucks and goods can interface with what we call the Verizon Edge Discovery Service to find optimal wavelength zones loaded with the customer application through our API. So this means as my goods move from maybe Dallas to South Florida, the data latency is held to a minimum by keeping those network hops down and sending data to maybe Dallas or Atlanta or Miami, depending upon where my goods are in the network, what that latency is to those wavelength zone sites, as well as if my application exists in those wavelength zones. Now, like Savi said earlier, data can then be analyzed right there at the wavelength zones, which can provide critical insights into what's going on in the trucks or within certain containers in the trucks, et cetera, and provide the ability to take action and prevent loss of goods when mere seconds matter, right? And not only is this a business advantage, but again, as Savi and Rob have mentioned, this helps to make the architecture and development and deployment much more flexible as well.
Great. And that was a great overview. And in fact, I've checked out the Edge Discovery services, and it looks like a great offering coming together. Big boon to developers for sure. And it's clear also that Verizon and 5G are integral to Wavelength, but I've also heard you mention Outposts a lot. So maybe we'll direct the next question to Rob to see if you have any additional thoughts or comments, Rob, on Verizon's role in Outposts.
Yeah, absolutely. It's early days for this edge business, right? It's early days for 5G, early days for Outposts. And like with every other service, we're led by our customers and our partners. And Verizon has been a terrific partner through our work at the edge. Coming soon, we'll have our new smaller form factor Outpost servers to allow us to bring that same EC2 experience to places where a 42U rack just doesn't fit. Or maybe more than a handful of servers is just more than that workload requires. I think we're going to continue to see Outposts reach farther and farther. We're going to see more countries, more geos, more metros, more services. And as always, we'll be led by our customers and led by Verizon and continue to build and provide what our customers need.
Great. Thank you, Rob. It's definitely, it's great to hear how all of these different components are working together and all giving customers a fantastic array of different options to best meet their needs. So really, really good stuff. Thanks for that. And so let's circle back around to, we've talked infrastructure, we've talked networking. So Wayne, let's come back to the data part of the puzzle here. So you represent the data processing piece of edge computing in that model. So can you talk about the role and value of a data repository at the edge for a moment?
Yeah, so we heard a lot about all of the new operational deployment options that you have, both on-prem, near-prem, and in the cloud, network continuity across wired and wireless networks, and the consistent development environment that these AWS services provide. And then when you bring a database in, the key thing about a database is when you have stateful applications, so these things like catalog, pricing, many other business use cases are stateful. They access data over time and they utilize that data for providing the services across their digital touch points. That statefulness must be backed by a database or a data store. And that's what Couchbase brings you. It brings you a consistent database with consistent interfaces that can be deployed for services in the cloud, for services at the edge across the many different options you have for edge deployments, and deployment directly on device with the networks, bringing that all together and creating this very powerful, consistent developer environment and development environment that provide these services as you see fit. Right. So what we see is a lot of different choices being made. You might deploy in cloud for certain use cases or certain areas of business and deploy out to the edge or on device as you see fit for your business needs. And then Couchbase and the database that it provides for backing the stateful applications are the key to those types of applications. And our consistent query interfaces for SQL, with SQL and eventing. We also have synchronization throughout, as I talked about before, and then, of course, security from the cloud to the edge and across each layer. So that's what the database really provides, is it takes you from stateless applications to stateful applications and the ability to synchronize data as it changes throughout the entire application and network stack.
All fits together, really, and that's fascinating to understand how these pieces work in tandem to really bring to life the vision of edge computing. So, and a lot of you have already teased out a little bit of use case examples. So I'd like to kind of pivot the questions to be more around what sorts of use cases that these emerging services and capabilities can actually enable. So let's come back to Pranav. Pranav, what industry use cases do you most often see supported with local zones?
Yeah, so customers from multiple industries are adopting local zones to unlock various edge computing use cases. The first use case that comes to my mind is real-time multiplayer gaming, where gaming companies like Supercell and Ubitus deploy game servers for multiplayer gaming sessions worldwide to be closer to gamers. And for these companies, a latency of 20 to 30 milliseconds or less is considered ideal for a good gameplay experience. And until now, these customers were using on-premises installations in various metro areas to supplement AWS region's presence. However, now with local zones, these customers are deploying latency-sensitive game servers in local zones to run real-time and interactive multiplayer gaming sessions, which enables them to provide end users across the US with a great experience. Another use case that we're seeing across the US is enterprise migration, where enterprises like Mindbody, who have workloads running in their existing on-premises data centers in different metropolitan areas, are using local zones for migration. Such customers have told us that it can be daunting to migrate a portfolio of interdependent applications to the cloud. And now, with the direct connect to local zones, customers can establish a hybrid environment that provides ultra-low latency communication between applications running in local zones and on-premises installations. And in turn, this enables customers to migrate applications incrementally, which simplifies migrations drastically and also enables ongoing hybrid deployments.
Very interesting. The gaming example and use case, fascinating, makes a lot of sense. I had not heard the hybrid migration use case before, but this also makes a lot of sense, and I appreciate you giving some thoughts on those. So let's pose the same question to Rob. What industry use cases do you most often see supported with Outposts?
Yeah, we've just been delighted by the number of different use cases we've seen, and sometimes you do see a use case similar to the local zone that just needs to be in a location where we don't yet have one. But we see some others in particular that are really Outpost specific, and one that's been really successful early is iGaming, which is not multiplayer gaming, but in fact online betting. It's increasingly becoming legalized across the U.S. And the tricky part about that is it's regulated on a state-by-state basis. So each state in the U.S., and it is certainly, it does exist in certain places outside the U.S. as well, it's regulated by a local regulatory body. And in most cases, they actually approve specific co-location facilities. And the bets need to be taken, and all the associated financial transactions need to be processed on hardware that physically sits in that facility. It's a terrific Outpost use case because a customer can deploy an Outpost with a reasonable amount of compute capacity to handle all that, to spike and satisfy the peak workloads on, say, the Super Bowl or another big, high traffic event in that industry. But then they can run their non-regulated data back in the AWS region, and they can use the same tools to deploy both. And we've had customers tell us that the operational improvement, not only deploying their applications, but reacting to issues when they arise, is just really, really powerful. Because before Outposts, they had a slightly different physical stack of hardware in each facility. So when there is an issue, which in many cases could mean they can't take a bet and are therefore losing revenue opportunity, they're disappointing their customers, they'd have to identify just what hardware is it, what firmware is it running, and then find the appropriate runbook to troubleshoot. But with Outposts, they can appreciate there's a consistent AWS deployment experience and just hop right into the application and begin troubleshooting, which lets them bring their services back online sooner and faster when they do have an issue. It provides a really powerful, simplifying benefit for these customers. Another space worth touching on is healthcare and life sciences. There's an increasing set of requirements and just sensitivity to keeping that sensitive, personal healthcare information secure and local, but having it in the medical facilities where there's a patient, whether they're there for an appointment and you don't want to have them sitting in a room waiting for latency to dial back to the region, or if they're actually having a procedure performed, and it's critical to have that data there in real time and have no jeopardy associated with taking more time to get the data. So we're seeing a tremendous amount of interest in the healthcare and life sciences segment as well. Financial services is another space where, again, similar to the iGaming, those financial transactions, that personally identifiable financial information needs to stay within the boundaries of the country. And Outposts let customers do that exactly when they need it, even if these regulations are rolled out quickly. And it gives customers the flexibility to easily migrate to a local zone if and when that is appropriate, and provides us with a really clear signal on where we should be looking at building local zones too.
That's a really great point that you made about the consistency of infrastructure helping you react to issues more expediently, and a great point, and another great advantage, I think, of these services and of Outposts. So let's now move to Brent on use cases. Brent, are you seeing specific use cases where the database plays a key role?
Definitely, Mark, for sure. I mean, aside from, the supply chain aspects of Outpost plus 4G, 5G, and Wavelength, I think the airline industry is another area that can leverage these types of architectures, not just in what you typically think with like telemetry apps, but specifically apps with distributed NoSQL backends, such as Couch. So these allow for, the untethered embedded plus the far edge plus the central cloud to kind of help manage things like bag tracking. And when you take into consideration the sync operations Wayne spoke of, which are critical when, we have all of those touch points, every piece of this, from the app and the DB to the server to the network, must be super, super fast to ensure consistency in these fast-paced environments. Take one of these baggage applications into consideration for just a second. You think about the bag as tied to a passenger, which is tied to a manifest, which is tied to specific gates at specific airports. And it must be, read-write, accessible to many different touch points, from ticket agents, gate agents, operations, and under the wing. And that tag and passenger will move across potentially multiple manifests before finally being offloaded at a destination baggage claim somewhere. So as you can visualize here, hopefully, the data hierarchy cascading out there. And I certainly don't want conflicts in records when trying to determine if my bag is on the plane or in the airport somewhere. So these low latency distributed architectures like these are imperative for these types of critical applications.
Well said. And yeah, it hits home when you talk about the potential to not know where your bags are. So definitely appreciate the benefits at a personal level even. So with respect to time, we might have to speed it up just a little bit, but this is a fascinating discussion. So Savi, I'd like to pose the same question to you about Wavelength. What use cases are you seeing in the Wavelength world?
So, certainly, Mark. As we know, like with Wavelength service, we are bringing AWS compute and services closer to the edge of the mobile network, and this can unlock many opportunities. And we are seeing many use cases. For example, one of our healthcare customers developing the AI ML-based video analytics and image processing solution to help doctors speed up diagnosis. And by fine-tuning, building, and refining their model in the region and decoupling and placing the real-time inference at the edge, now they're able to take the image and video streams from the medical devices and process it in the wavelength zone in real time and return the response back to the medical professionals to take appropriate actions. And this ability to do real-time inference with ultra-low latency, it's like having a second set of eyes to concur the diagnosis. So that's one use case we are seeing in healthcare. And there are many use cases in the media and entertainment. For example, with wavelength zones, we support GPU instance type, G4D and 2 extra large. And this allows our developers to deploy media servers for video processing, transcoding to output formats such as WebRTC streams, for live streaming high fidelity video and high fidelity audio, as well as embedding interactive experiences to the live streams. And we have seen wavelength zones leveraged for AR/VR applications as well. There's with wavelength now you can bring AR/VR applications to locations where it would not have been possible to do so because there's not enough space or power capacity to deploy local server systems. And by accessing the compute resources on AWS Wavelength, AR, VR applications can reduce that motion to photon to render latency to the desired benchmark so that they can deliver realistic customer experiences. As one of our customer puts it, it will change the way you watch sports and live events with 5G and AWS Wavelength. And another important platform is connected vehicles. And this is for enabling intelligent driving, perception mapping for road safety, being able to detect hazards and notify the driver and the infrastructure in real time HD mapping, and secure communication between the vehicles and the infrastructure. And so these are some of the use cases that can be enabled with 5G and AWS Wavelength.
And I can't wait to take advantage of some of the AR and VR. So watching sports is going to, like you said, it will never be the same. So excited about the potential here. So Wayne, let's circle back to you for a moment before we kind of end out our panel today. Customers have been using Couchbase for edge computing across nearly all of these industries and use cases discussed, I think. Can you talk for just a couple of minutes about a specific use case that comes to mind?
Yeah, one of the things that jumped to mind as Rob was talking about data locality for both latency and sovereignty, and even changing sovereignty requirements. And the way Brett talked about the importance of low latency read and writes at the edge as data changes throughout the entire application stack. The use case that comes to mind for me is Louis Vuitton's use case, where they were enabling their employees within their retail stores worldwide to have access to their entire product catalog at sub-millisecond speeds and 100% availability. And the way they did that was, and they were dealing with both data locality issues and latency at the edge. So they spread their core data network across North America, Europe, and Asia, and then had each of their worldwide retail stores. They deployed devices out to all of their employees. This is something they had already been using for some time. But what they wanted to do was put devices with embedded databases directly on those devices, and then distribute the data to those different locales through that top-level backbone that I talked about. And what they were able to achieve is the ability for their employees to access everything about their database, everything about the inventory in their system in real time, 100% of the time. And what they saw within their employee adoption rates is they actually had an application before that was built on a cloud architecture, and they had very low adoption rates. And I'm just remembering from memory here, but I think it was something in the 20% or something like that they shared with me. This was quite a while back. And then when they deployed the edge computing solution, where when the employee needed that tool, and they need these tools while they're in their store, what do we have? Where does it exist? What are the different materials that it comes in? What are the cleaning options for each of these products? When they need that tool to tell them the answer to all of that questions, they can reach in their pocket and grab it, and it works all the time. And they have the answer within milliseconds. And it's just a massive, massive change in the way their employees actually use that tool. Their adoption rates are massively high now, either the 80th or 90th percentiles of adoption. So very low adoption rates when you have a tool that you can't depend on in an employee base, and very high adoption rates when you have an important tool and you can guarantee availability and performance of that tool. So a massive success for them, and something that I think works well in this in the many great.
Great. And it really reinforces, it's a great use case, Wayne, thank you, and reinforces that Louis Vuitton is relying on Couchbase to provide that premium customer experience as well. And that's what elevates them ultimately, and their customers, to being more loyal and shop there a lot more. So I wish we had a lot more time, because this has been just such a fascinating discussion. It's really clear that edge computing, with this inherent low latency, is going to enable innovations like AR, VR, smart factories, autonomous vehicles, and robots, but it can vastly improve existing applications in retail and finance and healthcare and gaming, where uptime and real-time responsiveness are critical requirements. So it's, edge computing is not just poised, it's already making an immediate impact on everyday life, thanks to this collection of emerging services that's coming to market. So I'm going to ask Wayne to sum us up in just a few seconds here at a technical level.
All right. Let me look through this. So what I wanted to do here was just give a summary of everything we talked about. We saw these great new deployment options. We heard about the consistency of the development environment, the consistency of the database access capabilities, and then look at what the actual real-time numeric capabilities are of each of these deployments. So starting with the cloud architecture, what we saw in our tests is you can achieve triple-digit millisecond latencies in many cases with a cloud architecture. If you move out to wavelength, you're going to be able to achieve double-digit millisecond latencies over those wireless networks that Verizon and others provide. With local zones over wired ISP, you can get single-digit millisecond latencies. And then when you go to AWS Outposts accessed over wired LANs, you can get even the single-digit millisecond latencies, so 1.2 milliseconds for that deployment. And then if you deploy on device, you get rid of all of the network latency and you get consistent sub-millisecond response times. And one of the other benefits you get from deploying on device is the 100% availability. You've removed all of the variability of networking from the distributed system and you now get the guarantees of availability also. So I think this is a great table that shows the deployment options and the capabilities from latency that you can achieve.
Agree. And I think this discussion has cleared up any questions for a lot of our audience as well. So I'd like to thank our panelists, Rob Czarnecki, Savi Venkatachalapathy, Pranav Chatra, Brent Eiler, Wayne Carter. Thank you so much for the fascinating discussion. And thanks to you in the audience for joining us. I want to remind everybody, don't miss the keynote presentations on day 2 of Connect, where IDC's Dave McCarthy will discuss his new study on edge computing and the edge services landscape. And our own Priya Rajagopal will go into detail on amazing new capabilities coming in the next version of Couchbase for mobile and edge computing. So once again, I'm Mark Gamble. Thanks to everybody. Thanks to our panelists. And I hope you enjoy the rest of our conference.